Okay, so now that we have discussed the context switch, let's go through some basic concepts about processes. Okay, so now I'm going to say stuff that in principle should, it's detailing a bit better what I just show you about the context switch. So what the computer executes is called process, okay? We don't use the term program because the program, it's a passive entity, it's what is stored on disk, while the process is the program once you start executing it, okay? When you execute it, you load it into memory. You can start, of course, programs and processes in different ways. The important thing here is that you can have a program that is composed of several processes, okay? And some processes can also be the execution environment for other processes, okay? And this is the example of the Java virtual machine. Now, when you want to run a process, you need to maintain information that belongs to the process itself. So you need a portion of memory in which you place the process, but you, the operating system needs also to maintain information about the process. I mentioned before that, for instance, you need to know whether a process is running or it's idle, okay? This is not information that belongs to the process, okay? It's information that the operating system maintains about the process. If we focus on the information that belongs to the process, okay, then we have different parts. There is the program code or the text section, okay? This is basically where you keep the instructions that you have to run to execute your process. There is the data section that contains global variables. And then there is the heap and the stack. The heap contains memory that is dynamically allocated while you execute the process, while the stack contains temporary data, okay, so function parameters, return addresses, local variables, and so on. Now, this schema here shows you the different states in which your process can be. When you tell the operating system to run a certain program by creating a process, the operating system sets the process state initially to new, okay? So the process is being created. Once everything is ready, the process goes into the ready state, okay? Ready means that it's not executing, but it can start to execute if it's given a CPU core. Remember that only one process can be running at each processor CPU core at any instant, okay? So from ready, you can go to running if the process is actually given access to the CPU core. It stays into the running state until it generates maybe a request for which it needs input or output, okay? So it says, I want to read something from the disk, for instance. In that case, the process cannot continue until it gets what it needs from the disk. But when there is input output, it doesn't go back to ready because it's not really ready to start again until the disk answers or the input output is completed. Because of this, it goes into a waiting state. And once what the process is waiting for is received, it goes back to ready because that is the point at which it's actually ready to run again. Of course, you can also go directly from running to ready if, I don't know, the clock, for example, generates an interrupt. So the process gets stopped because something else needs to run, but the process is not asking for some kind of input output. So you can just go back to the ready state. And finally, once you are running, you might also decide to exit and be terminated once you execute your last instruction. Now, this is the context which I presented before. Okay, so when the CPU switches to another process, we said that the system must save information about what it was doing and what it will be doing next. Because of this, it stores the information about the process, not the information of the process itself that stays in memory. And this information is what is contained in the process control block, or PCB. As I said, context switch is an overhead, so you want to minimize the time it takes to do the context switch, and you also want to minimize how many context switches you do if possible. And you need support from the hardware, okay? You need, for example, interrupts from the clock that periodically allow the operating system to wake up and check what is happening. This is the information we have in the process control block. Okay, you can read the slide by yourself, but just to point out some interesting stuff. One important thing is the program counter, which is basically the location of the next instruction to execute, or better said, the address in the main memory that belongs to the text section of a certain process in which the next instruction to be run is stored. Okay, you can have registers about registers from the CPU. You can have accounting information about the CPU use, clock time elapsed, and so on. Information about input output, whether the process is waiting for something or not, and so on. Just have a look at this list.